Alright, so welcome to our second lecture for our Eduonix course on socket programming in C. And today we're going to be talking about the HTTP protocol and how we can implement that on top of the socket protocols that we looked at in the last lesson, TCP. So for a quick review, like we talked about last time, sockets are the basic building blocks of network communication. They're how we connect to things on the internet, and more basically, though, how we make connections between any software. So if we want to request a website, get information from a particular web server, at the most basic level, we can use sockets. And most of the information on the internet, the information that we can access using the HTTP protocol, which we're going to be looking at implementing in today's lesson. So HTTP is built on top of the existing TCP protocol, and in our last lesson we looked at creating TCP clients and TCP servers. So these use the lower level protocol, which just basically specifies the connection, and then after that, you can send back and forth any kind of data that you want when you're just implementing the TCP protocol and writing an application that acts as TCP client or TCP server. So for HTTP, we use the TCP protocol, but what changes is the data that we send back and forth. It needs to have a specific format, and it needs to basically the client needs to tell the server what information it's requesting, and then the server sends back that information. So HTTP has this sort of request and response cycle. On the client side, the client sends a request for data, and the server responds with a response that has a particular format, and on the server side, basically the other end of that. So we're going to take a look at implementing both the client and server side of this protocol. So in HTTP, we start with sockets, but on the client side, we write some special data to the server first to ask for a particular resource. So in a lot of cases, we just request a particular file or whatever information it is we want to access. And we send that request to the server. It's the first send command on the client side. And then the server responds back with a particular response, either containing the resource or information as to why that resource could not be returned. After the HTTP server has received the request from the client, it either retrieves the resource and returns it back in what's called the response body, and sends back a status code that lets the client know the resource was retrieved successfully. In this example here, we see the server sends back the status code that's on the first line. 200 is a status code that means everything's okay. And in the response body, we should find whatever we requested. So in a lot of cases, when you visit sites on the web, that's HTML. So that's the data that you get back, and then you can see the HTML rendered in your browser. In a lot of cases, that's what's making the HTTP request. But however you're making the request, the response gets sent back to the client, and then the client does whatever it needs to do to process that data, and then can continue sending further requests to the server. So in order to get a better understanding of how sockets work underneath the HTTP protocol, we're going to start by implementing an HTTP server that we can access from our web browser, and that renders some HTML for us that we'll implement using sockets and C. So let's get started with the server. So like in the previous socket lessons, we're going to need actually most of the same include files. Standard IO. Standard library. We're going to need one additional include, since we're going to want to manipulate the string data that we're working with here in order to build our HTTP response from the server. We're going to include the string header. That's just string.h. And then the usual socket headers, types, socket, and the in.h. And then we can create our main function. So, since most of the response is actually pretty standard in sockets, all we need to do is really just send some data out to any clients that connect. The first thing that we're going to need to do that's going to be different than the socket programs that we've written thus far, including the TCP server, is we're going to need to get the data of the file that we're going to be using as our HTTP response. So we want to render an HTML file, or we want to send an HTML file as part of the HTTP response. So we're going to use the C methods for opening and reading from files in order to do that. So first, we're going to need to create a file object to hold the information from our file and read from. So we can create a file pointer to hold the data. And then we'll use the fopen function from the standard library in order to open a index.html file, and then we'll use that to read. So the first parameter to fopen allows us to specify the file that we're going to open. In this case, that'll be our HTML file. And that's what our server is going to serve. It'll be the response body that our browser will get back. And the second parameter is basically an indicator as to how we want to use the file that we're opening. W indicates that we're going to write to the file, and R indicates that we're going to read from the file. And since we want to read, the second parameter will be an R. So, since we have a file object, we need an actual string to store the HTML of the file in it. We'll just call that response data. And we're going to make it big enough so that we can hold a decent bit of information in here. Then all we need to do to read from the file is we can call the fgetS function and read it into this response data string. The first parameter is where we're going to read the data to. The second parameter is how much data to read. We're going to fill up the whole thing. And then the last parameter is the file that we're reading from. So in this case, we just specify the HTML data file object we created with the fopen function. So this is basically all we need to do to open our HTML file and read it into our application. So this is the only part that doesn't really have to deal with the sockets. From here on, we're going to be implementing basically what looked like the TCP server, with a couple of changes that need to be standardized for the HTTP protocol. So first we're going to create that first line of our response. In the slides, we basically said this is the line that has the status code that lets the client or whoever's making a request to the server know what happened when a particular resource was requested. So we'll create a string for that. And we're going to make it pretty big, and we'll see why in just a second. But we're going to specify an HTTP response here, and we're going to basically put the following text in. HTTP, then a version number. We're going to use 1.0. Or let's use 1.1 here. We specify it after the slash. And then 200, and then OK. So this is just basically like a response header that lets the client or any particular client know the response for the resource that we've requested is OK, and we're going to return the data that we requested in the body of this particular response. And then we need to end that with some new line characters so that it's formatted properly. You use \r, then \n, and then another \n. And after that, this is where we're going to put the data of the actual HTML file. So the main reason why we included that string header is because since we have our response data, we want to combine the response body, which is the HTML file, and the response header, which is the line that we just wrote, the HTTP 200 OK. So we'll use the strcat function. It basically will concatenate the two strings, add them together, so we get one string that contains the entire response body, both the header and the actual data of the file that we're supposed to be serving. So we can just use the file and specify the two strings, and it'll add one into the other. And we can use it like this. So I've added the data from the response data string into the HTTP header, so that's why it's so large. It can now contain the data from both the header and the anything that was in the index.html file. So after this, we have fairly standard socket code. And this just goes to show that underneath the HTTP protocol basically works on top of the same kind of framework that we were looking at for writing the TCP server. HTTP servers just send particular content in the responses and requests. But it's basically a TCP connection gets made and data gets sent back and forth in a similar way to the TCP server. So you create a server socket in the same way. Still the same parameters as the TCP server information. We create a server socket with the socket function call, specify internet domain, and a stream socket for TCP, and no additional flags. Then we define the address again with that sock address in structure. So this defines where our server is going to serve the data. So we're just going to go ahead and bind it to any local interface and a particular port, so we can access it straight from our web browser on our local computer if our code is running properly. So in order to do that, we define the members of this structure like this. We specify the family. That's still AF_INET like above for the socket. We specify the port next. And here we once again use that h2ns function to convert the port number to the right format for this particular structure. I'm going to use 8001 here for this example. And then the address itself, and we're going to use any address, that constant that's defined. once we have the address defined, we can bind our socket to a port using the bind function call like before. And the syntax for that is going to be the exact same as the TCP server. And then from here, things are mostly the same. We listen for connections on that socket again. And then we're going to create a placeholder for the client socket. And that's a connection that's going to get opened. So the next part of the code we're going to wrap in an infinite while loop, because this is the part that we want to happen forever. We want the server to continue serving and responding to requests. So we create a while loop. The condition while 1 just basically means that this code will continue to execute forever, until executed, or rather interrupted by the operating system. Like if you hit Control-C on your server or something like that, send a signal to end the process. So we're going to accept a connection on the client socket. And we're not going to store the address, so the parameters for accept are going to stay null and null. Then we're going to send some data back to the client. We're going to send the HTTP header since that contains our entire response now. Like before, we have to pass the size of the HTTP header to the send function. And then we close the client socket. Send also takes a flags parameter that we're going to set to 0. I'm just scrolling down a little bit so we can see the rest of the code. So that's basically it. The implementation of an HTTP server. This is obviously very simple. Most HTTP servers do different things depending on the kind of requests they get. They will parse the actual header and figure out whether what resource a particular request is looking for, and maybe you want to do something different depending on what's being requested. That's a lot of the ways that you have dynamic web content. And a lot of times you want to do something different because of the request method. So in our examples, we're going to use get, and we can take a look at get, since that's what our browser does. Our browser mainly does gets when we type in the URL of a particular web server. But there's also post requests and update requests, delete requests. There's a lot of different kinds of requests you can make to an HTTP server if you're doing a full implementation of the HTTP protocol. This is just basically a server that responds with the appropriate HTTP headers for the response and a status code. But there's a lot more that you can do in a full-featured HTTP server. But this is basically how you would start developing the building blocks for that server. It works off top of TCP sockets, and it's basically really similar to running a server in TCP. The only thing that changes is the data that gets sent back and forth. So we can actually go ahead and open a web browser after this is done, and we should be able to, well, first let's write some sample HTML to test this with, and we need that index.html file that we refer to up here. Once we write that file, we'll put some test data in there, and then make sure it gets served, and we'll open it in the browser. So before we get going, just 2 quick corrections. We're missing a semicolon on this line, and there's also one additional header that we have been including for the other server socket. applications that wasn't included here, and that's the net inet in.h. So make sure you include that. So now this code should compile properly. We're not going to put too much complicated HTML in here, just some text that we can make sure gets rendered appropriately in our web browser. We're not going to go over the HTML specifics for this class. You can basically copy the tags exactly as you see here. We're not going to go into too much detail about what's what. We'll just have an HTML and body tag. And that's really all you need. So now we're going to go ahead and make the executable. Make sure everything compiles properly. And then we can run the server and access it from our browser. So I've opened a web browser and navigated to localhost, since that's basically the same as that's a local IP that's bound to our machine. It's an interface that we can access. And navigated to the port number, and as you can see, the HTML that our web server is serving gets shown to the screen. So if we go ahead and change that HTML and reload the page, the appropriate thing will also get served. So as you can see, when I hit refresh, our server is actually serving the content from that file. It's loading it from our file system, and since it's in a string, we're rendering it out to the browser. This is basically all you need for a basic, simple HTTP server that doesn't implement a lot of special dynamic web logic. So now that we've implemented a basic HTTP server, we're going to take a look at what happens with sockets on the other side. What sockets need to do in order to request data from an HTTP server. So we're going to start building an HTTP client. And it's going to have a lot of similarities to the TCP client, but again, the data that gets sent back and forth is going to differentiate. There's also a couple more operations this time as opposed to just sending or just receiving data. We're going to need to do both, since in HTTP, a client makes a request for data and gets a response, and the response is basically the information. So let's go ahead and get started with our HTTP client. So again, most of the same libraries. Then once again, socket and types. So we include the rest of the regular socket headers, socket and types. And then there's one additional header we need to include this time. The include looks like this. It's ARPA/inet.h. That's INET. And this additional header contains a function for converting network addresses. And since this program is going to be a little bit versatile, we're going to need to, in the same way that we need to convert our port number integers with a function, we also need to convert our IP address formats to something that our structures can actually work with. So a function from this header is going to be able to do that for us. After these includes, we can write our main function again, but we're going to add the parameters to it this time. Main is going to take an argument count and a list of arguments this time. And this is basically the number of command line arguments that we pass in, and the argv list is a list containing all of the actual command line arguments. And the 0 index element of this list, I believe, is the actual name of the program. So we're going to want element 1 if we want the first command line argument passed to this program. Since this is a TCP client, we're going to use the command line argument to specify what server we're going to be connecting to. So to start, we're going to grab the address of the server from the command line arguments and store it in a pointer. This is basically all we need to do. We create an address character pointer, and we store the first command line argument in that pointer, in the character, rather. And then we continue on by writing a regular TCP client program. We start by creating a client socket again. We connect it to an address once more. So we're going to use port 80 because that's the port that most web servers run on. But we specify it the exact same way we have been doing before. And the last line is what ends up being different. So we're going to call the new function that we've included from this header file. It's inet a to n. It looks like this. So this basically converts the string address that we have stored from the command line argument and converts it into a format for our address structure so we know how to connect to it properly. So the first parameter is our string address. That's the command line argument. And then the second argument is where to store the converted address. So we're going to pass a pointer, essentially, or rather pass a reference to the place where we had been storing our addresses before, the structure inside of our address structure. Previously, we used to place the inet any value there, but in this case, we're going to pass a reference to it to this function, and it'll store the address of the converted IP that we pass in as a command line argument to this function. So remote address is our structure storing the address information, and the SIN-ADDR structure is a struct in which we store the real address information. And so we're passing it as a reference here to store the real address information from this function that will get converted from the IP that we pass to this program we're running from the command line. So from there, like before, we connect. We call the connect function on our socket and connect it to the address that we specify. And that call looks exactly like bind. So we call connect. We connect our socket to the remote address. And then really quick, let's create two variables to hold a request and a response. Again, I'm going to make this response variable really large so that we can actually hold all of the data that we get back from the various clients that we might be requesting information from. So I haven't actually specified the request yet, because that's going to be our actual HTTP request, like we talked about a little bit in the slides, and I'll explain what all of these things mean. So the very first part of any HTTP request, as according to the protocol, is the method. It's what you're doing with a particular resource on the server. So in this case, we're going to get. The next thing that's part of our HTTP request is what resource we're going to get. We're going to specify a / to just say, basically it's like the root location on this particular server. It's like when you request a website without specifying a particular page. That's what this / is going to indicate. And then we specify the version of the protocol we're using. That's HTTP 1.1. And then, like before, we use \r and \n to denote that we're finishing up this request. And we're going to use two of these here. So we have our HTTP request. So now that our socket connection is already made, we first send the request using the send method on the socket. So this is basically all we need to do to send a HTTP request, similar to the send calls that we've seen earlier with our TCP client and server. And after we're done sending, we receive the response using the receive method. We pass the address of the place we want to store the response. And again, both send and receive take an optional flags parameter that we're just going to set to 0. So now that we've sent our HTTP requests and received an HTTP response, we are going to print out what we got back from the server. We're going to use a format string to basically give us some extra information, format it a little nicely. Use a new line at the end of this here. And then we're going to close the client socket. So we send our HTTP request. It's a GET request for a particular resource. And then we receive data back from the server right after that, and we're going to print that out. So like our basic HTTP server, this client is just sending GET requests. But there's a lot of other methods that you can perform on particular resources in the HTTP spec. Much like the server, there's GET, update, delete, there's a bunch of different things. But since this is a really basic HTTP client, we're just going to get resources, and that's kind of what we were able to do with our browser. So let's test this client out and make sure everything works properly. So when you attempt to compile the HTTP client, you might get a warning about your call to the inet A2N function, but you can safely ignore that for the purposes of this. The program should still have compiled, and you can pass it some IPs and start testing it to make sure it works properly. So to test it out and make sure I can get some data back from any particular server on the web, I'm going to use our HTTP client to grab some data from google.com. So I'm first going to grab the IP of a Google server. I'm going to use ping to just find that out really quickly. So you can see here we get an IP, and we can use our HTTP client to request some data from this IP. So as you can see, we get back a full HTTP response. Like in our server, we got back a first line containing a status code and HTTP version message, and then some more headers, basically metadata about the response from the server, and then we get some actual content from the page. Some HTML, some text, things that you might see when you actually load the page in your browser, but this is just giving us the raw content of the response body. So using both the HTTP client and HTTP server, you can get an idea of how we can use sockets to underlie all parts of the web process, both on the client and server side. Sockets are used to actually implement servers, respond to requests from clients. We just looked at basic examples, but you could extend these with more functionality and actually have a fully featured web server directly with the sockets technology we looked at in C. So this kind of gives you a little bit of an idea of how sockets are the basic building block of network communication. On both sides, extending these applications would lead to some of the full-featured things that you'd see on the web. You could display dynamic content in the same ways, but it all works based off of sockets. So we've covered how sockets work and how to implement applications with sockets. And from there, that's really sort of the basics of getting started with socket programming. For more information on implementing specifically the HTTP protocol over top of sockets, there's good information available freely on the web. If you want to get in depth, you can go ahead and read RFC 2616, and that has all of the information. It's a comprehensive guide on everything you need to fully implement HTTP, all of the methods and everything involved, what needs to be defined on an HTTP request and response cycle.
So we've taken a look at the basics of doing socket programming in C. We've kind of got a good understanding now of TCP socket programming, how the connections work, and how we can send messages back and forth on the sockets. So let's just quickly do a quick recap of what we've looked at in the 2 lessons so far. So this is kind of the basic 2 workflows that we looked at for TCP clients and TCP servers. Sockets are the basis of our network communications, and with TCP, this is the commonly used protocol across the web for most of our operations. Our web browsing uses TCP, and that's how your web browser requests data from a particular web server. TCP is the base protocol, but on top of it is HTTP, the protocol that specifies what data should be in the messages that we send back and forth. An HTTP server sends a response to a client, which first has to send a request containing a particular method and some header information, and then the server will respond back with data, as we saw in both the HTTP client that we built and the HTTP server that we built. So these workflows hold true across the board for making connections on the client and server side. So while we looked at just implementing the basics, there's a lot more in depth we can go with socket programming in terms of implementing particular protocols. But as far as the API goes, most of that stays the same with whatever you want to implement. If you're looking for more information about how to implement a particular protocol, you can look at the links that are there on the right, or just do a Google search for RFC 2616. This is the actual specification document that is comprehensive and contains everything about the HTTP protocol in case you want to implement a full-featured HTTP server. But the basis of it will still be the same. You'll still use the same socket calls and commands to connect to a particular IP and port, using the socket functions, creating a socket, and then sending or receiving data on one side or the other of the socket connection. For more information about the socket functions themselves, you can, on your Linux machine, if you're using Linux, look at any of the following manual pages by using the man command. There's one for socket, and then the send and receive commands, but also the bind, connect, accept, and listen commands that we looked at. If you type in a manual page for any one of the socket commands that we've looked at, you'll get a really detailed, comprehensive piece of information about everything that can be used in that function, all of the arguments, and some just more drilled down information about how to use those functions and the different things, like, for instance, the flags that we weren't using on send and receive commands. So that's basically all we're going to look at for our socket programming course. And like we said, for further information, there's resources here in case you want to go more in depth about any of the higher level concepts that we've talked about. So that's it.